Okay, I'm sorry about that. There was a problem with my audio. I think it's working fine now. All right. Assalamu alaikum, everyone. I hope you guys are all well. So we are starting with uh, today's class. Then in the last session, we started with coordinate geometry. We discussed some basic concepts. We started with this, how to find distance between 2 points using the distance formula, midpoint of 2 points, how to find the gradient of a line joining 2 points. We talked about the interpretation of gradient. Gradient tells us the change in y coordinate if the x coordinate increases by 1 unit, right? That's the interpretation of gradient. Uh, when do we have positive gradient lines? When you have the line going in the upwards direction from left to right, and the line is going in the downward direction from left to right, that's a negative gradient line. Horizontal lines have gradient 0, and vertical lines have gradient that is undefined. We sometimes call that gradient infinity as well, but the more accurate mathematical terminology for that is that the gradient is undefined when the lines are vertical. We talked about parallel lines. Parallel lines have equal gradients. Perpendicular lines have gradients which, when multiplied, give us -1, or in other words, we can say they are negative reciprocals of each other. So if you know one gradient, you can write down the other gradient using that, because the gradients are negative reciprocals of each other. Okay, we did some examples in this. Then we talked about how to find equation of a line using y equals mx plus c form. That was one possibility. And the other form that we talked about was y minus y1 equals m into x minus x1. Both forms can be used to find equations of any lines. When you have the gradient given and the y-intercept given, or when you have the gradient given and a point given uh, apart from the y-intercept, or when you have 2 points given and the gradient is not given, you can use any of these two forms to find equations of lines in all of these cases. So you need to know both of them. The first one is going to be more efficient than when the y-intercept is given. And the second is going to be more efficient when the y-intercept is not given, even though you can get away with knowing just y equals mx plus c as well and do everything with that. But if you know this second form, it makes some problems more efficient if you find the equation using the second form when the y-intercept is not given. So that's what I would recommend. And the y-intercept is not given, that you use the second form. That's what we covered in the last session. And then finally, we talked about how to find gradient of a line from its equation. So if you have the equation of a line given, how can you find the gradient of the line using that? Okay, so that's what we covered in the last session. In this case, we basically just convert the equation to this form, y equals mx plus c, and whatever is the coefficient of x, then that is the gradient of that line. Okay. All right. Now, we talked about equations of lines in this form in the last session when they are slanted lines like this, going like this or this, right? When they have a positive gradient or a negative gradient. What if we have lines like this, where the gradient is either 0 or undefined? What happens in that case? So for instance, if there's a line like this is y-axis, this is x-axis, and let's suppose we have a horizontal line. We have a horizontal line that looks like this, and let's say it's passing through this point 3. What's the equation of this line? This line would have equation y equal to 3, because the y coordinate at every single point on this line is 3. Only the x coordinate is changing. So no matter what the value of x is, the value of y is always 3. The equation of this line looks like this, y equal to 3. You can think of it using y equals mx plus c as well, because it's a horizontal line. Since it's a horizontal line, the gradient is 0. So it becomes y equals 0x plus c. And you're just left with y equal to c, where c is the y-intercept of this line. and the y-intercept is 3. So you can say the line has equation y equals 3. But for any horizontal line, you can now keep this in mind. The equation is going to be of this form: y equals some constant. Y equals some constant. The equation will always be of this form whenever you have equation of a horizontal line. It would look like this. Okay, horizontal lines always have equations of this form: y equal to something, y equal to some constant. Then what about vertical lines? What if you have vertical lines? For instance, let's consider this example. We have an x-axis here, we have the y-axis here, and there's a line that looks like this. It's a vertical line with the x-intercept, let's say, being -2, and it's a vertical line. What's the equation of this line? Vertical lines have equation of this form: x equal to something. Okay, in this case, what's the value of x? It's -2 at every single point on this line. At every single point on this line, the x coordinate is 2, right? No matter x coordinate is -2. No matter what the value of y is, x coordinate is always -2. So that's why the equation of the sign is x equals -2. Now, in this case, the equation is not of the standard form. It's a different form. It cannot be written as y equals mx plus c, because in this case, there's no y as such. And the gradient is undefined, right? So m is undefined. Since m is undefined, we cannot write it in that form. It's of this form: x equal to something. And that means whenever you have a vertical line, the equation of the vertical line is always going to be of this form: x equals some constant. Okay, horizontal lines have equation y equal to some constant, and vertical lines have equations that look like this: x equal to some constant. Otherwise, when you have a line that is either a positive gradient line or a negative gradient line, those lines equations can be found using y equals mx plus c. For horizontal and vertical lines, you should remember these particular forms. For horizontal lines, y equal to a constant. For vertical lines, x equal to a constant. Okay, all right. Now that's how you can write down the equations of lines. We talked about the other kinds of lines in the last session already. Then you should also be able to find x-intercepts and y-intercepts of lines. X-intercepts and y-intercepts. And this is actually a general concept that does not just apply to lines, but to any function. Let's say I have a line like this. So I have x and y axes. This is y axis, this is x axis, and there's a line that is going like this. And let's suppose the equation of this line looks like this. The gradient could be -1/2. In that case, it would be 2y plus x equal to 6, let's say. So we have this equation: x plus 2y equal to 6. This is an equation that I have. Okay. This is the equation of this line that I've drawn here: x plus 2y equal to 6. Now, what we want to find out is, what is the x-intercept of this line and what is the y-intercept of this line? Now, x-intercept is the point where the graph cuts the x-axis. That's this point here. And the y-intercept is the point where the graph cuts the y-axis. So this is the y-intercept, the point where the graph cuts the y-axis. We call this the y-intercept. And this is the point where the graph cuts the x-axis, the x-intercept. Okay. Let me write that down on the side as well. X-intercept is the point where a graph cuts the x-axis. It crosses the x-axis or cuts the x-axis. And y-intercept is the point where the graph cuts the y-axis. How do you find these points for any function? the x-intercept and the y-intercept. For x-intercept, what you do is you put y equal to 0. Why is that? Because the point lies on the x-axis, right? Y coordinates look like this. Let's say this might be the point 3. This might be 6. This might be 9. This point might be -3. What's on the x-axis? The x-intercept is when the y coordinate is 0, right? So above the x-axis, we have positive y coordinates. Below the x-axis, we have negative y coordinates. On the x-axis, the y coordinate is going to be 0. Okay. So whenever you have to find x-intercept of any function, what we do is we put y equal to 0. And what about the y-intercept? The point where the graph cuts the y-axis, it will always have an x coordinate of 0, because you can see again, on the right side, the x coordinates will be positive. On the left side, they will be negative. On the y-axis, the x coordinate is going to be 0. So in order to find x and y intercepts, what we do is we put y equal to 0 and x equal to 0 respectively. So in this equation, if we have x plus 2y equal to 6, if this is the equation, and we want to find the x-intercept and the y-intercept, how do we do that? For x-intercept, we say, let's input y equal to 0. What do we get from that? X plus 2 times 0 equal to 6, and the value of x turns out to be 6. That means this point is supposed to be 6. And for the y-intercept, what we do is we put x equal to 0, and that gives us 0 plus 2y equal to 6. Y equals 6 over 2, and that is 3. So the y-intercept of this graph is 3. Now, it's not just for linear functions, it's for any function that you will see. Quadratic functions, cubic functions, reciprocal functions. For any function, if you have to find x and y intercepts, this is what you do. For x-intercept, put y equal to 0. For y-intercept, put x equal to 0. All right. Okay. That's about x and y intercepts. Now, the next thing that we want to understand is finding equation of perpendicular bisector. Now, these are all small concepts, but you need to make sure that you understand all of them, because you get like 1, 2, 3 mark questions on each one of them. Perpendicular bisector. Finding equations of perpendicular bisector. Okay. Now, what is perpendicular bisector? Let's understand that. Let's say you want to find the equation of the perpendicular bisector of the line joining, or you can say of the line AB, such that the coordinates of A and B look like this. Let's say the coordinates of A are 2 and -3, and the coordinates of B that are 5 and 6. So we have these 2 points. What we want to do is we want to find the equation of the perpendicular bisector of the line joining these 2 points. Now, what is perpendicular bisector? Perpendicular means that the angle of these 2 lines is going to be 90 degrees. They'll be intersecting with each other at an angle of 90 degrees. Bisector means cutting something in half, something that cuts another thing in half. So bisector means it should cut in half. Okay. Perpendicular means 90 degrees angle. Bisector means it should cut in half. Now, what does that mean? Let's mark these 2 points, A and B. Let's say point A is here, and then point B has a bigger x coordinate, a bigger y coordinate. Point B might be somewhere around here. So if A is here, we could say B is maybe this point here. So we have these 2 points. We have the coordinates of both of these 2 points. And what we're interested in is finding the equation of the perpendicular bisector. Now, what's perpendicular bisector? If I were to join A and B, I would get this line, right? Perpendicular bisector is a line that passes through the midpoint of AB. It passes through the midpoint of AB. Why? Because it has to cut AB in half. That means it has to pass through the midpoint of AB. And it should be perpendicular to AB. So it would look something like this, such that the angle that it makes with AB is 90 degrees. So it would look something like this. Okay. And you can say this angle here is 90 degrees. This is perpendicular bisector. We want to find the equation of this perpendicular. Okay. Now, how do you find equation of this line now? For equation of any line, you need two things. You need one point on the line, and you need the gradient of the line. These are the two things that we need to be able to write down the equation of perpendicular bisector, right? If we can find those two things, we can write down the equation. Now, do we have a point on the line? No. Do we have the gradient of the line? No. Both of these things are not known for now. Can we find both of those things? Well, think about it. Since the perpendicular bisector has to pass through the midpoint of AB, this midpoint, let's call this point M, it will lie on the perpendicular bisector. So we can find the equation of the coordinates of the point M first. We can start by finding the coordinates of the point M. How can you find them? That's the midpoint of AB. Let's find that. So that's the first thing you do. You find the midpoint of AB, which we're calling M here. What's the formula for midpoint? X1 plus X2 over 2, Y1 plus Y2 over 2. You can call any of them X1, Y1, and then the other would be X2, Y2. 2 plus 5 divided by 2 minus 3 plus 6 divided by 2. What do we get from this? 7 over 2 and 3 over 2. This is the midpoint. We can call this point M. We have found the coordinates of this point. Now, this is one point that lies on the line. Okay, so that was one thing that we were looking for. What's the other thing that you need to be able to write down the equation of the line? You need the gradient of the line. How do you find the gradient of this perpendicular bisector? What you can do is you can find the equation of AB. So the gradient of AB, right? And then since perpendicular bisector is perpendicular to that, we know that gradients of perpendicular lines are negative reciprocals of each other. And using that, we can find the gradient of that as well. Okay, so let's do that. Let's find the gradient of AB first of all. So the next thing we do is we find the gradient of AB. Gradient of AB. What does that turn out to be? Y2 minus Y1 or X2 minus X1. That will be 6 minus 3 divided by 5 minus 2. And that simplifies to 6 plus 3, which is 9. 9 over 3, that's 3. The gradient turns out to be 3. Okay, that's the gradient of the line AB. We are not writing the equation of AB. We want the equation of the perpendicular bisector. Okay, so what would be the gradient of the perpendicular bisector then? It will be negative reciprocal of this gradient of perpendicular bisector. Negative reciprocal of this, change the sign, take reciprocal, that becomes negative 1 over 3. Okay, so now we've got both of the things that we need. We have the midpoint of the line and we have the gradient of the line. Using these two things, we can write down the equation now. We can use any of the two forms, y minus y1 equals m into x minus x1 or y equals mx plus c. But remember we said when y-intercept is not known, y minus y1 equals m into x minus x1 is going to be more efficient. So I would recommend that you use that. Y minus y1 equals m into x minus x1. It's going to be less work this way. What's the point that we're going to use? It's a very common error that students end up using one of these points, A and B. That would be incorrect, of course, because the perpendicular bisector does not pass through A or through B. It passes through the midpoint. Okay, so you have to use the midpoint and the gradient, which is minus 1 over 3. Let's use that to write down the equation. Y minus y1. What's y1? That's 3 over 2. So this is the point. We call this x1, y1 now. And this is the gradient. We call this m for the equation of the line. Y minus y1, that becomes y minus 3 over 2 equals m, which is minus 1 over 3 into x minus x1, which is 7 over 2. That's the equation of the line that we were looking for. Generally, they would ask you to write down the equation, write down the final answer in this form, y equals mx plus c. So now what we can do is we can make y the subject in this. How do you do that? Let's simplify everything first. Y minus 3 over 2 equals minus 1 over 3x plus 7 over 6. Y equals minus 1 over 3x. 3 over 2 goes to the other side, gets added to 7 over 6. 7 over 6 plus 9 over 6, that will be 16 over 6, and that's 8 over 3. You can do this on your calculator as well. If you get something as complicated as this, mostly it would be on the calculator paper. If not, you can take LCM. 7 over 6 plus 3 over 2. You can take LCM of that, and that will give you 8 over 3 as the result. This is the equation that we were looking for. That's the equation of the perpendicular bisector. All right. So in order to find equation of perpendicular bisector, what do? We first of all find the midpoint of the 2 points that were given. Then we find the gradient of that original line, take negative reciprocal of that. That will be the gradient of the perpendicular. Once we have those two things, we can write down the equation using any of the two forms, and that will give us the result. Okay, so that's how we find equation of perpendicular bisector. That's another thing that you need to know. Any quick questions on this? Any problems? No problems? All right. Let's move on. Now, the next thing is when you have some points given and you're required to find some missing point. Now, let me explain what I mean by that. So I'm going to label it like this, using a vector method to find any missing points. Now, this is very important to understand. Let's take an example to understand what I mean by this. Let's say I have a line like this, and we have the endpoints of this line as points A and B. Okay. And there's a midpoint of this line, and that midpoint is called M. And now what happens is I know the coordinates of the point A. Let's say they are -3 and 6. I know the coordinates of the point M. Let's say these coordinates are 1 and 1. And what I need to do is I want to find out the coordinates of the point B. Okay. So given that M is the midpoint of AB, let me write that down here. M is the midpoint of AB. Given this information, find the point B. Find the coordinates of the point B. Now we know the coordinates of the point A, we know the coordinates of the point M. What we do not know is the coordinates of the point B. How can you find this point B now? One idea could be using the midpoint formula. That's one idea. You can use that. And what you would do for that would be, you would say the midpoint is known. Let's call the coordinates of B X and Y. Okay, let's call the coordinates of B X and Y. And now you can say the midpoint of AB is given as 1 and 1, right? We know that the midpoint of AB is 1, 1. What we can do is we can find our own midpoint using the midpoint formula. We know the point A, we know the point B. Use the midpoint formula and see what you get from that. minus 3 plus x over 2. Add the x coordinates, divide by 2. Y coordinate 6 plus y divided by 2. That equals 1, 1. Okay, so we find our own midpoint and we equate that to the midpoint that they have given us. That's 1, 1. And now what you say is the x coordinate here that we have should equal the x coordinate that they have in their midpoint. And the y coordinate that we are getting, it should equal the y coordinate that they have given us. And from that, we get two equations. We get minus 3 plus x divided by 2 equal to 1. Or, in fact, and 6 plus y over 2 divided by 1. And now we find the values of x and y from this. Multiply 2 on the other side, and that will give you minus 3 plus x equal to 2, x equal to 5. From the other equation, you get 6 plus y equal to 2, y equal to minus 4. And that means that the coordinates of the point B are 5 and negative 4. All right. This is one idea. This is one way to find this missing point. Okay. But it requires you to solve some equations like this. That is one possibility. Okay. We could do it much more efficiently using a method that we call the vector method. And that works like this. Let's do that same example now using a slightly different idea. So now, instead of using the midpoint formula, what I can do is I can use this method that I'm calling the vector method. How will this work? We think of it this way, that, okay, M is the midpoint of AB. We look at how many units do we have to go horizontally. How many units do we have to go horizontally in order to go from A to M? I'm sorry, just give me a second. Okay, how many units do you have to go horizontally in order to go from A to M? Think about it. We have minus 3 here, we have 1 here. So how many units are we going horizontally in order to go from A to M? Minus 3 to 1, that is 4 units in order to reach this point M. Now M is the midpoint of AB. So how do you get to the x coordinate of B? You go 4 units more to the right side. Okay, you go 4 units more to the right side. Now the point A has coordinates minus 3 and 6. That means this point was supposed to be minus 3 on the x coordinate. This is going to be 1 because this is 1. You add 4 more to that so that this point becomes 5. 1 plus 4, that is 5. That means the x coordinate of B is going to be 5. Similarly, if you look at it on the y-axis, what's the y coordinate of the point A? The point A has a y coordinate of 6. So this point on the vertical axis is 6. Now, if you go to the point M, what's the y coordinate of the point M? That is 1. How many units do you have to go in order to go from 6 to 1? You have to subtract 5, right? You have to go 5 units down. What you can do is you can reach the point B now by going 5 units down further. So 1 minus 5, what would that be? That will be minus 4. So the y coordinate of B therefore should be minus 4. Okay. Now you can do this working in your exam like this. You would say A is minus 3, 6. M is 1 and 1. You write these coordinates like this. A is minus 3, 6. M is 1, 1. And M is the midpoint of AB. We write B down here like this. And now we write it like this. We say, okay, how do we go from minus 3 to 1? How many units do you have to add or subtract in order to reach that point? We have to add 4, right? Minus 3 plus 4 gives us 1. How do you get to the get to the x coordinate of b then? You add 4 more to it. So you do 1 plus 4. What does that give you? That gives you 5. The x coordinate of b therefore is going to be 5. Okay, and again, how do you go from 6 to 1? How many units do you have to go in order to get to 1 from 6? You have to subtract 5, right? You have to do minus 5. You do minus 5 more, and that will take you to the y coordinate of the point B. 1 minus 5, that's going to be minus 4. And these are the coordinates of B that we were looking for. This is much quicker than the midpoint method. The midpoint formula is going to work as well, but this other method, the vector method, you can actually use that in your head directly and write down the answers. And that's much quicker this way. Okay. Let's take another type of question that you can use the vector method for. Let's say we have a parallelogram like this. Let me draw one here like this. So we have this parallelogram. Let me see if I can tilt this somehow. Okay, I can't. What I'll do for that would be okay. So I have this parallelogram. Okay, I just need to redo this. All right, so I have a parallelogram like this, and let's say it looks like this. The coordinates are, the vertices are A, B, C, and D. All right, it's a parallelogram. That means the opposite sides are equal and parallel, right? So it looks like this. And now in this parallelogram, I know that the coordinates of A are unknown. Let me write down the coordinates of D, C, and B instead. Let's say D has coordinates 2 and 1. Then C has coordinates 6 and 3. And let's say B has coordinates -3, the y coordinate, and let's say the x coordinate is 5. Okay. So we have the parallelogram in which we know 3 vertices. We know the coordinates of B, C, and D. And what we need to do is we need to find the coordinates of the point A. Now, how can we do that? How can we find the coordinates of the point A? Again, we can use vector method. Remember, the opposite sides are equal and parallel. What that means is, whatever is the number of units that I have to go horizontally and vertically in order to go from C to D, it should be the same units that I have to go horizontally and vertically in order to reach the point A from B. Okay. In order to go from C to D, it should be the same units horizontally and vertically that I have to use in order to go from B to A. So I can think of it like this. Okay, I know the point C. The point C is 6, 3. I know the point D, that is 2, 1. I know the point B, that is 5 and -3. Now, how do you go from C to D? What do you have to do for that? In order to go from C to D, you have to go 4 units to the left, right? That's -4. So in order to go from B to A as well, since it's a parallelogram, the opposite sides are equal and parallel. In order to go from B to A as well, you would have to go 4 units to the left. So you go 4 units to the left, and that will give you the x coordinate of A, which is going to be 1. Okay, and similarly, how many units do you have to go on the y-axis in order to go from 3 to 1? You have to go 2 units to the left, that's -2. You go the same number of units on the y-axis in order to go from B to A as well, and that will give you 3 minus 2, and that is 1. So the coordinates of A therefore are 1 and 1. Sorry, that's not correct. It should have been minus 3 minus 2, that's minus 5. 1 and minus 5. These are the coordinates of the point A, 1 and minus 5. Okay, so we can use vector method to find this missing point here in a parallelogram as well. Okay. So this is going to be extremely useful when you have a situation like this. It often comes in this midpoint scenario, when you have the midpoint known and you have point on one of the sides known and you have to find the remaining point. You can use the vector method for that like this. Or when you have a figure like this, a rectangle, a square, a parallelogram, a rhombus, in all of them, you can use this idea that the opposite sides are supposed to supposed to be parallel and equal. So the opposite vectors are equal. That means whatever is the number of units that you have to go in order to go from C to D, it should be the same number of units that you have to go in order to go from B to A. All right, I hope that makes sense. That's pretty much all that you need to know in coordinate geometry. I'll be uploading a worksheet on coordinate geometry today as well. If you understand all of these concepts, well, you should be able to do all the questions from that. And if you have any questions, you can let me know in the next class then.